Hi, everyone. Welcome to our webinar today. Our webinar today is Connecting Energy Literacy and Climate Change Education. My name is Sarah Urquhart. I'm a research assistant with the collaboration between the Ontario Institute for Studies in Education at the University of Toronto and the Toronto District School Board. And today I'm joined in this space by my colleague from OISE, Dr. Hilary Inwood, and the team from the TDSB Sustainability Office. We have Alicia Roberge, Chris Metropolis, and Jen Vetter. And this webinar is also hosted in collaboration with Accelerate Climate Change Education, which is a national project funded by Environment and Climate Change Canada and co-led by Dr. Hilary Inwood from OISE and Dr. Ellen Field from Lakehead University. So there's a poll as you're entering today. If you could please let us know a little bit about you, who's in the room. And we encourage you to introduce yourself in the chat so we know who we're speaking and joining our space with today. So for our webinar today, I'd like to share a land acknowledgement, and then I'd also like to introduce our speakers for today. We're going to hear from Alison Bradbeer from Relay Education, and then we're also going to hear from our TDSB team about energy explorations related specifically to the Toronto District School Board. And we'll end today with a Q&A time, and then also share a few of our upcoming events, things you might want to know about for the spring and the months to come. All right, so to begin, I want to introduce you to an artist. This artist is named Jackie Fawn from Fish Bear Studios. And Jackie Fawn has Indigenous roots from Yorick, Washoe, and Surganon, which are areas that we would now know as the United States, otherwise known as California, Nevada, and then also from the Philippines. So I wanted to highlight Jackie Fawn's work because this is an artist who is really known for their depictions of really strong Indigenous female warriors protecting land, water, and people. And this particular piece, it's unnamed, but it's been used by the organization Indigenous Environmental Education. And they use this to depict a just transition. So when we talk about a just transition, we're talking about a movement towards a low carbon or no carbon economy that really does center equity and social inclusion. And so with that reminder, for myself and others joining from Toronto, we want to acknowledge that we are hosted on the lands of the Mississaugas of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit peoples. So for those of you who might be joining from other places, feel free to acknowledge the traditional territories from where you're joining in the chat. We will be focusing on that idea of like just transition, looking forward to how we can include energy education in a way that really does connect to social and ecological justice. Today's webinar was coordinated based on teacher interest, and in exploring the topic of energy, how might we think about energy literacy? Why might we want to include this in our teaching? And what are some practical strategies to actually engage students in energy literacy? So to do so, we've invited Relay Education to share with us a little bit about the how and the why of energy literacy. And so I'd like to welcome Alison Bradbeer. Alison Bradbeer, she's an OCT with junior, intermediate, senior qualifications and has worked in environmental education for about 15 years for various not-for-profit organizations. And Alison is currently the GTA coordinator for Relay, where she coordinates all the booking and the scheduling for GTA staff while also running workshops themselves. So very busy, Alison. And if that's not enough, in the summer, Alison runs workshops as part of the Outland Youth Employment Program, YEP, in remote northern communities for Indigenous youth, and also with the Toronto Public Library summer camps. So also doing this, you'll want to know Alison is also a TDSB secondary occasional teacher, working at Kapapamachakwe Wandering Spirit School, Native Learning Center, and Subway Academy 1. So I'm going to let Alison share a little bit about why they think energy literacy is important and how we might do this work in our classrooms. So I'm going to pass it over to you, Alison.
Okay. So thank you so much for having me and Relay Education as part of this webinar today. We're really thankful that we could be involved. I'm going to start out just a little bit about who Relay is and sort of what our missions are. So If you've never heard of Relay before, we are a Canadian charity delivering high quality programming about renewable energy, conservation, climate change, and green careers, not only in Canada, but across the world. And our mission is 100% renewable energy future, meaning a healthy and prosperous planet for everyone. And the production and use of energy affects our health, our planet, and our economy. And to reach our vision of 100% renewable energy and mitigate climate change, we need you and our communities to take action. So that is our mission as an organization. We do offer a whole bunch of in-class workshops that are linked to STEM, as I said, across Canada and international. Some of the topics that we teach about are wind and solar power, biogas, water, electrical safety, green collar careers, and climate change. So those are just some of the things that we offer in class. Relay is also really interested in energy literacy already. We have a page dedicated to energy literacy. And we believe that how energy is generated and distributed has a tremendous impact in our communities, from household electricity bills to pollution and local jobs. So it takes informed people advocating for local sustainability energy initiatives for this change to occur. And we really believe that energy literacy is essential for youth, so your students, as they become future leaders and environmental educators and advocates. So beyond the classroom, energy literacy is key to making informed decisions about where our energy comes from. And with the right approach, everyone can learn how to become responsible energy consumers. So I think that's why one big reason that Relay is such an advocate for energy literacy. So I'm going to start with a section on why energy literacy is important for our classrooms, and then we'll move into the how. So I think that energy literacy equips students with a lot of knowledge to make informed decisions, not only about energy usage, but sustainability and climate action. And I think it fosters critical thinking and problem solving so that students can be engaged in a lot of real world challenges. It also is a demand for there's a demand for skilled workers in renewable energy as this sector grows. These concepts support STEM education, so we need to encourage that more and more in schools, because there are going to be more and more green careers available. Also, there's a lot of energy literacy that aligns with Ontario curriculum, so it kind of makes it easy for you to integrate that into existing lessons when we have them written up already in our policy or in our curriculum documents. So let's get into each of these. I'm going to kind of break them down. So energy literacy is very important for future sustainability, because as we strive to reduce greenhouse gases and transition into low carbon economies, I think students need to understand how and why different energy usages impact climate change, and what solutions are needed. And with our vast natural resources in Canada, ranging from oil to solar, we need responsible management and to transfer from fossil fuels to 100% renewable energy. As I said, that's our mission, at least for Relay. It's important to teach students how to reduce energy consumption, I think, on an individual level. So it not only promotes sustainability, but also helps families save money when they take home these ideas. So knowledge on things like efficiency ratings or electrical vehicles, home heating technologies. These can make cost-effective and sustainable decisions in students and their families' lives. If we want to go on a bigger scale, as Canada aligns with global agreements like the Paris Agreement, understanding how international energy trends influence national policies and industries, the economy prepares students to navigate and contribute to these energy landscapes. And as future voters and professionals, they also need energy literacy for roles that they might take in government, for policymaking or corporate sustainability, even in energy finances, to ensure that the fossil fuel industries can be held accountable for their part in our environmental destruction as it is right now. Energy literacy can also help students develop critical thinking skills by analyzing trade-offs from different energy sources at the same time while considering economic, environmental, and social impacts. So for instance, understanding how electricity grids function, or like why blackouts happen, or how energy storage works, it can deepen their grasp on complex energy systems. And throughout problem-solving challenges, students can explore real-world issues, such as addressing energy poverty in some remote communities, or doing design challenges where they design more energy-efficient buildings. And we'll talk about some of those later in the hows. So I have some questions for you. I wanted to test some of your knowledge before we go any further, just about energy in, let's start with Canada. So as a wider look, I guess you guys can pop these in the chat. So first question is, what percentage of energy in Canada comes from renewable resources? So you guys can throw those in the chat. So I'm going to pull up.
Allison, are you counting hydro?
Yes. Okay, so we have one guess of 70. Anybody else want to guess? Okay, 25%, 50, 60 or 70. Good, okay, I'll come back to that answer in a second. And then what resource is most widely used in Canada for electricity? Either renewable or non-renewable. Okay, we have one guess for hydro. Nuclear, it does count, yep, as a resource. Gas. Okay, so here's our outlook on Canada as a whole. So in terms of renewable energy, overall, Canada uses about 69% of renewable energy. So you can see here, hydro is the most used across our country. So uranium is nuclear, and then with our natural gas, coal, solar, biomass, wind, yeah. Good. Yeah. If you guess too low, that's great, because then yeah, it shows that we're doing even better. Okay, let's have a smaller view now. So same questions, but let's just talk about Ontario. So same questions, what percentage of energy in Ontario comes from renewable? And then you can also guess what resource we use most in Ontario. No, so nuclear, it was just overall energy. And I didn't include that in the renewable percentage. Good. Okay, so we have 60% nuclear, Ontario, potentially 85%, 60%. Okay, let's have a look. We have some good guesses. So for Ontario, our renewables output is about 38% almost for renewables. Again, our most used resource, not renewable, but resource, is nuclear here in Ontario, followed by hydro at almost 25%. But we do have a huge solar usage, which is fantastic, and wind, which is also great. So good job. That's just just for context, for everyone to see what we're talking about when we're talking at a provincial level and at the countrywide level. The next thing I want to talk about are some challenges and misinformation or myths that could be out there that you might encounter while you're trying to teach and while you're looking through some energy literacy. So the first one is about energy storage. The challenge is that especially for wind and solar, they are intermittent resources. So they do require storage solutions to kind of ensure that there's a reliable supply. But battery technology has its limits at the moment, especially its efficiency. So you may come across that as one negative or challenge. But with new grid scale storage, things like pumped hydro or compressed air, things are improving the reliability of those usages. Another challenge is distribution, right? Not everywhere has the renewable resources to depend on for 100% usage. And it might be a challenge trying to integrate renewables into existing power grids. But we're again on the right track as smart grids are developing and energy balancing strategies come, we can help maintain those stabilities. Expense obviously is something that we talk about quite a lot. And while costs for things like wind and solar have dropped significantly in the past couple of decades, kind of the initial output can be quite high. But wind and solar are now among the cheapest energy sources, along with the savings from outweighing that initial cost. So again, great solutions. One piece of misinformation that I get regularly when I do our wind program, both from teachers and students, is the idea that wind turbines kill lots of birds. This is definitely the misinformation that I hear the most. And while it is true, wind turbines do cause some bird deaths. In a 2020 study of the 6,600 wind turbines that we have in Canada, they found that about 54,000 birds were killed annually. But if we compare that to domestic cats that are allowed to go outside, domestic cats kill about 100 to 250 million birds in Canada annually. So what wind turbines kill is just a fraction of what regular cats do. So that's my stat that I like to pull out because it's minuscule in compared to cats. One way that we can mitigate these bird strikes, though, is having one blade painted black. So there was a study done that painted one blade black, and it reduced bird mortality by about 72%. So in the future, you may start to see wind turbines that have a color or stripes on one blade. And what it does is it breaks up that invisibleness when they start spinning faster so that the birds can see it much better. Yeah, so that's just some information you may come across. And it's always good to have like both sides from challenges to the real information. Okay, let's get back to why energy literacy is important for the classroom. This is a huge one that's really important for your students. Energy literacy is really crucial for preparing students for careers in STEM, as well as skilled trades and policy-related roles. Canada's energy sector is evolving, and understanding these energy systems' sustainability and efficiency can open doors for diverse careers for students. Additionally, it encourages entrepreneurship in inspiring new technologies and sustainable businesses. This excerpt is from Clean Energy Canada and NABIS research, where they say Canadian jobs in clean energy are set to grow about 7% a year from 509,000 in 2025 to about 2.5 million in a net zero scenario by 2050, which is fantastic. So that's a great shift. So students need to be ready. There is, again, this demand for these green jobs. And while there will be about an estimated 1.5 million job decline in the fossil fuel industry in a net zero scenario, with less reliance on oil, this far exceeds the 2.2 million job increase in the energy sector that we could see. So with these loss in fossil fuel jobs, those people in that industry can transition to renewable energy jobs through targeted training programs that focus on transferable skills like electrical work, mechanical maintenance, and project management. So it is possible that people can be retrained for a net zero future. So here are just a quick rundown of some jobs that students could potentially go into if they are interested in green collar careers. So things like solar engineers, solar panel installers, energy analysts, wind turbine technicians, wind energy engineers, hydroelectric plant operators, marine energy researchers, biomass engineers, and geothermal technicians. Right, so those are all things that are really focused in the green collar career sector. There are also jobs that are kind of adjacent, things that might be a pathway to careers in energy. So things like electricians that may work on solar panel and EV chargers, HVAC technicians, plumbers that work with energy efficient water heating systems, energy auditors and building inspectors for new sustainable homes and buildings. And then once they're in these sectors, they can get certifications and trainings, red seals for many trades, energy efficient training through CEM, which is the Certified Energy Manager, or BOC, which is Building Operator certification. And then there are new storage solutions needed, and there are certification courses in battery technology as well. So things that they could look into once they are once they've graduated. And lastly, for why energy literacy is important, as I said earlier, is that it aligns closely with curriculum goals across lots of different subjects. So science, environmental studies, physics, chemistry, and geography and social sciences. And also a big one is Indigenous studies. So Indigenous studies can also highlight the leadership of many Indigenous communities in clean energy projects, which can then foster respect for Indigenous knowledge and supporting reconciliation efforts. So what I've done, and I don't expect you to read all of them, but I went through all of the curriculum documents. We all have access to those. And it's really easy just to pick out curriculum connections that are for each grade, whether you're elementary or secondary. So here are curriculum connections for grade 1 to 8. And then here is some connections for secondary, right? We have different sciences and then tech, green industries, and Energy Lit is really great for any of the SHISM programs. So if your school has SHISM, and depending on the sector, you for sure will be able to integrate some of these. And I think the best, if you are teaching any specialist high school major, is to use the ICE activity. So that's the innovation, creativity, and entrepreneurship, like major project for SHISM, and doing it for something in the environmental field can be great for your students. So SHISM has a great connection. And then these are Indigenous study connections. Again, here are for the environmental, for elementary, social studies, science, and then language and lit, and then some connections for secondary as well. So again, I didn't expect any of you to read through that, but at least it gives you the ideas that you can go into those documents and pick out things for your grade or your subject, and have a look at how you can connect energy literacy directly with the curriculum. Okay, so let's transition into how we can bring energy lit into the classroom. So a few things we can talk about: real world examples using current events, local and national information. We can include Indigenous perspectives, leverage online resources, hands-on activities, and field trips. So for using current news and real world examples, we can, sorry, I'm just looking at the time. I might go over a couple of minutes if that's okay. Just a couple. So teachers can integrate energy literacy into their classrooms by examining current events and highlighting the intersection of energy policy and policy decision-making documents. So for example, use what's happening right now in the world, right? You can use the trade tensions that we have with the US, talking about Trump's tariffs. You can talk about Doug Ford's response to that with the 25% surcharge that he discussed putting on energy going into the state. So use things that are happening right now that are current. By analyzing some of these developments, students can then explore political leadership at both federal and provincial levels. And this can inform them, once they become age, on how energy platforms of various leaders can affect their future. So again, we will have a vote coming up soon. So discuss platforms between, Polyev and Carney, and discuss those in your class as well. If you want to use real life energy projects that are close to home, here are some in Ontario. So I just have a list on the screen. So we have Henvey Inlet, which is a wind farm, and it's the largest wind project on First Nations land. There's Niagara Falls. There's the Six Nations Grand Renewable Energy Park in Haldimand County, which is a solar and hybrid project. You can look into Gull Bay First Nations, which is a micro solar grid. So it's off grid, and it has solar and battery storage. There's Toronto's Deepwater Lake cooling system that you can talk about, how the water in Lake Ontario cools buildings in the downtown core. There's the Oneida Energy Project, which is a battery storage project in southwestern Ontario, and the Fort Severn Solar Project, which again is another off-grid energy solar project. So as you saw in the previous slide, many Indigenous communities are at the forefront of energy projects, and teachers can enhance energy literacy by incorporating case studies and inviting Indigenous leaders and knowledge keepers into the classroom to discuss how traditional knowledge aligns with renewable energy initiatives. So Indigenous teachings often will emphasize like the balance between nature and through concepts that I've listed on here. So it's Edawumptamunk, which is two-eyed seeing. You can talk about the 7 generations principle, the medicine wheel, and viewing water as a sacred resource. So these are all ways that you can help students understand energy from the Indigenous perspective. You can go online. We have lots of online resources for energy literacy. If you want specific for Indigenous PD resources for teachers, there are a few that I've listed here. There's the 4 Seasons of Reconciliation. I think it's about a 3-hour online course put out by the Truth and Reconciliation Foundation. I've taken it. It's great, good information. There's a course right now offered by Western University, which is called Connecting for Climate Change Action. I'm taking it right now. Again, it's really informative and it's all from Indigenous perspectives. You can take the First Nations, Métis, and Inuit peoples AQ, to help you gain insight. And you can use Natural Curiosity, which is a website and organization that has a lot of PD. It can be self-led. There are webinars, there are workshops that you can take, but those are just really great resources for you. And then as you guys can read on there, there's a bunch of websites. And I've given a lot to Sarah as well that she can share with you, different resources, many more than I've shared on here. I think the best way to bring energy lit into the class is through hands-on activities. So first is joining eco schools. I'm not going to talk too much about that because I know we have Alicia here from eco schools, so she may talk about that, but it's a great opportunity for you to maybe start an eco club in your school and reach for certifications in your school if you can, and do lots of things with students that are not just only in your class, but you can bring them all together. And then doing things like utilizing experiments, simulations, design challenges to explore different energy sources. So one of those ways is by looking at things like energy bills that you can bring into the classroom. You can have students compare appliances like Energy Star versus regular, or compare LED light bulbs to incandescent. Do a classroom or a school audit. Do waste audits. Talk about unnecessary lighting or inefficient heating and cooling, the use of phantom power, and then have the students give suggestions or solutions so that they can think about their school at, for solutions for their own school. And then other fun things that you can do, I've listed them here. You can make your own solar oven, do renewable energy models, thermal insulation experiments where you're looking at different materials to see which last longer, which might be better for buildings, battery storage challenges, looking at different types of batteries, and energy policy simulation. So having debates in classes where everybody kind of takes a different role. Lastly, so this is my last one, I promise. A great way is to do field trips and have guest speakers in the classroom. So I have a list of really great places that you can take your students to learn more about energy usage in and around the GTA. So Toronto Zoo has their biogas plant where they use organic waste like the poop from the animals to make energy. We have our wind turbine downtown, so the wind share and relay education, the turbine that's at the exhibition place is, we're 50% shareholders of that. So we're hoping to have tours back up and running in 2026. So that's something, if you're interested in, we can talk about that. You can have tours of the deep wave cooling systems. You can go to Niagara Falls or Grand River. And having guest speakers in the classroom bring in people like Indigenous knowledge keepers, renewable energy experts, environmental scientists, and researchers, government and policy experts. If you've ever had a chance to talk with Diane Sachs, she's our former environmental commissioner of Ontario and an environmental lawyer. She's fantastic to talk to. I've had the pleasure of speaking with her a number of times, and she's lovely. Educators and environmental organizations like Ontario Society for Environmental Educators or Relay Education, we can come in and talk. Youth climate leaders from places like the Starfish Canada, farmers and agricultural energy co-ops, and green techs. Just as a last plug, if you are interested in ever having Relay, one of our programs is Plug in the Sun, where we talk about renewable versus non-renewable energy, and then we do experiments with solar panels. And if you choose our extension, we do a solar challenge where kids get to make these solar cars and race them, and then your classes get to keep them. So that's something hands-on that you can bring us in to do for your classroom. So thank you so much for giving me time to chat. I hope that you have some good ideas to take back to your classroom, and you've learned something new today. So thank you so much.
Thank you so much, Allison, for sharing a little bit about it, for testing our own energy education and to see what we know about energy in Canada and in Ontario. And I would just like now to introduce our next sort of portion, which is going to be from the TDSB team. I'm going to introduce Jen Vetter, Chris Metropolis, and Alicia Roberge, who are going to now start to share a little bit about how we can bring some of this down to a local level. So what does energy literacy, what can it look like within the TDSB, and how can we use some of the things that the Toronto District School Board is doing as a board, but then the information that's available to teachers in our classrooms as well. So I'm going to pass it over to Jen.
Sarah, thanks, Allison, for your great presentation. As Sarah just mentioned, we are going to talk about energy at the TDSB. So Chris is going to walk us through, what are our emissions, what can we do about conservation, and ideas for working with your students. So Chris, please take it away.
Thanks, Jen. And when we think about emissions, there's one in particular that is a big deal. And if we take a look at the city of Toronto, this is from 2022, but quite easy to see the lion's share comes from heating and cooling buildings. And if we take a look at the TDSB emissions from 22-23, the big piece of the pie is natural gas, and the small sliver is electricity. So we have control mostly over the electricity part in schools, turning off lights and devices, but unfortunately it doesn't really have a big impact on greenhouse gas emissions, but it does have other impacts. In terms of the public sector, we can see what the emissions picture looks like. So here are universities, and the bigger the circle, the bigger the emissions. We've got all the cities in the province, hospitals, and finally school boards. And no surprise, Toronto has the most emissions out of all of those groups. U of T's in third place. Any guesses on who's second? Yeah, that's us. And if we take a look at school boards in particular, if we look at the top 4 emitters, we can compare square footage and emissions because there is a relationship. And you can see right away, TDSB is at least twice as big as next biggest board at Peel. And if we layer in the emissions, we can see a slightly different story there. Yes, they are aligned, but York and Peel look like they're the most efficient. Their emissions are lower than their square footage, whereas TDSB, we appear the least efficient. And this is borne out in other data that says exactly that. And if we think about energy intensity, which is both electricity and natural gas kind of mixed together, we are above the Ontario average. And I think we can imagine we have a lot of the oldest schools in the province that have a lot of maintenance backlog. So that's part of the problem. And if we take a look at schools that are missing things like steam plants or pools and whatnot, the numbers get better, but they're still above the average. It gets even worse when we think about emissions per square foot. We are 53% above the average, as opposed to 27% when they're mixed together, or the energy intensity, I should say. And so if we could imagine that we reduce the TDSB's emissions intensity by 20%, we would be closer to the average, not quite, but we would also save almost 13 million a year just by doing that. And so more on this plan in a moment. What we can do though is we can find out energy information from your school. And a couple ways to do this. If you go to good old TDSB web and in the quick links, you can go to facility services, or you can click on the school utility profiles banner that's right on the left there. Any of the data that you see in this portal can be downloaded in CSV format, and you can play around with with that data with your students. So if we click on that banner, we would come to the energy page. If you go to facility services, it goes to their home page, but you can click on energy in the link on the side there. And there's annual data and hourly data, which is pretty interesting, but not all schools are connected for that hourly data collection, but that's getting rolled out over time. We're going to start by looking at annual, just because every school has that, and click on a set of years that you want to look at. Once you do that, you then get to pick your school. So common tool we have for picking our schools, you can type it in or however. And the first page that you get to see when you choose your school, we're picking on AY Jackson only because they're first in the list. But we can see right away what our emissions intensity is overall versus natural gas intensity and electricity. And unfortunately, AY is not doing so hot compared to the average TDSB school. They've got above average numbers there. And there's probably some good reasons for that. Maybe things need fixing. And so we have our energy department that looks at the school data, and if there's anything glaring, they start to look deeper for any issues that can be fixed. And you also get to see some other info about your school up at the top there, what the square footage is, if you have portables, enrollment, if you've got solar panels, if you've got a pool. You probably know that. But all that can affect the numbers that you see. There's a separate quick links menu on this page that lets you visit all kinds of different information about your school. So good quick way to do that. We can also find the latest 2024 energy profile in this menu, but it wasn't on the first page we looked at. Notice that there's a tree maps choice in there, and Alicia would certainly love you to explore that. She may talk about that a little bit later. There's a number of different graphs that are part of this energy profile, and so you can click on that center list to go straight and choose one, or you can click on the next button and that just cycles you through. So the first one is the total greenhouse gas emissions from your school. It's weather normalized, which should balance things out a little bit, depending if we have really cold weather one year. Obviously, you'd use more energy. But the thing to really notice from the total greenhouse gas emissions is that the gas numbers are so huge compared to electricity. So that goes back to that first pie chart we saw where 93% of our emissions come from natural gas. This shows a different way of looking at that. The other thing about AY here is they seem to be going up on the gas usage, which is not great. Now, this is kind of post-COVID, so it may be more people are in the school and they have to heat it more often than had been done before, but still alarming to see it keep going up. How can we turn it around? And if you want to download any of these graphs, click on that little arrow kind of icon, and you can select either an image format or CSV. Just below that is a little infographic of some real world comparisons to vehicles and homes. So just another way for your students, especially, to understand what these numbers mean and compare them to something they hopefully understand. Another graph will show you monthly usage. And so this is great to see any kind of trends between years. Maybe November in 2021 was way colder, or sorry, warmer than November in 2023, hence the increased usage. So that's something that they can research. Another one that's kind of interesting, if you have solar panels, it'll show you how much you generate versus how much you use. It depends on how many panels you've got on the school. So that's AY Jackson. Just keep in mind that the solar panels don't power the school. That power goes into the grid, which probably just goes to the end of the block and then turns around and goes back to the school. But that is how the situation is. You can take a look at your solar generation by month. Again, which months were sunnier than the year before. Gives you a good indication. And here's another point to drive home about gas versus electricity. So if you have solar panels, this shows you how much emissions you've avoided by putting clean energy into the grid. And you can see, again, it's a very small sliver compared to the gas usage at that school. I'm going to take a look at some of the hourly data because that is kind of interesting. Another great way to check to see if things are working properly. But here's actually today from Adam Beck. They're hooked up, and you want to see that peak in the sort of in the morning and then tapering off. That's a pretty normal thing to see, and we can compare weeks. So if we click on that compare weeks option, then we can see what happened. And this is the week before, which of course was March break. And you want to see it at lower usage during when people aren't there. Is it still too high for March break? Maybe. Maybe I don't think there's a daycare at Adam Beck, but something's going on. And this was all electricity, so we can switch up at the top left to natural gas. And here we're comparing the same 2 weeks, this week and last week. Again, maybe the usage seems a bit high for people not being in the building. Maybe the schedule's not set properly. And so that's something our energy team would look at and say, hey, you could set a schedule for March break and have it much lower. So what happens now? That's a good question. We have all this data, and one thing that we're trying to use with this data is something called Campaign 20%, which is again getting us closer to the provincial average. There was a pilot that ran in LC1, although it's kind of the old LC1, which was half of LC1, that is the way it is now, just to optimize the use of BAS schedules to turn machines off when people are not in the building. And that's the heat plus fans and whatever equipment's connected. And by just doing this, optimizing the schedule, we had some pretty profound effects. So there were 6 learning networks in LC1 at the time, and you can see that actually 2 of those, LN3 and 4, they ran the pilot for about 11 months. The other ones were 1 to 2 months. So even with that short period, we had some pretty good reduction in greenhouse gas emissions, overall 7% in less than a year. If we just make that real nice and big, we had some big cost reductions. This money can now be used for further upgrades and maintenance to make our system even better. And of the almost 2.4 million kilograms of greenhouse gas avoidance. That's about 1 million liters of gasoline in less than a year that was kind of saved. And again, almost $1.4 million. So pretty crazy. The plan is to roll this out across the whole board, and that will start in September. And if we hit 10% savings across the board, we'd be saving 13,000 tons of CO2 and about 5 million a year. If we do that 20% across the board, 26,000 tons and 10 million. And if, however, we manage to get to 45%, which is our aspiration, we would now be among the top performing school boards instead of above average. And we would save 60,000 tons about and 24 million a year. So imagine all that money going back into maintenance. It'd be pretty great. So that's our goal, starting September, campaign 20%. It's going to be advertised pretty heavily. We do have some existing targets sort of left over from that pilot that they're hoping by August to hit 10% in reduction in emissions and a savings of almost 1.8 million. So we'll be able to report back in September if that happened. There's another pilot going on with Enbridge, Pay for Performance, which I think is changing up some of the heating units in 8 schools. And so that goal is 20%, which should be pretty exciting. And then hopefully that continues to roll out after the pilot. And now I'm going to pass this over to Alicia to talk about energy literacy.
I'll be really quick. I'm just going to go over just a few little things that you can do in the classroom. So Earth Hour coming up, so March 21st at 2 p.m. We'll have it on our newsletter, the details for there. And Chris, you can go to the next slide. I'll just go over quickly the lessons.
And don't forget, you can check out that hourly energy profile to see if your lights are making a difference.
Most schools are on it, so you can check it out. And if you have any questions, just ask us as well. So for the points as well, switching off lights and devices, and then this energy data that Chris has just showed you can really help you with kind of looking at your school and the energy footprint that your school has. And we'll quickly go to the next slide. I'll try it in your classroom, and we'll just run through this. So downloading it in CSV or downloading it into Excel. So you could do CSV to your Google Suite, and you can create infographics in Google Forms, or you can use the Excel sheets to bring into ArcGIS. You would have to use a CSV file for that. And then you could make a dashboard like the one that you see there. You can also create something like a story map, and that way you're pulling in different kind of graphics. You're using many different tools to and entry points. Students have fun working with that. There's no ceiling for them when they're working with that. You can poll students. So Survey 123 can be used to collect that data or to check on data. So Chris mentioned the tree data beforehand, like looking to see what's planted in the school property. Has that changed? Has that tree, been removed, or is there a new one? And with energy data, maybe what students think in the school, how are they using, what are their opinions on the usage. So I was playing around with Mark Arno, because that's where I was beforehand, looking at the data from 2000 when I started all the way to today and comparing weeks that way. So there's a lot of different things you can do. Have the students play with it, inquire, ask questions. They don't have to come up with the answers. It's all about just playing with the information and pulling it into these applications, or pulling it into just like, working with, pen and paper and developing those questions and inquiring and getting to know about these uses, and maybe hunting for some of the losses that we might be having. And then finally, just mapping. So the map on the left-hand corner there, the orange dots is just the solar panels. That's okay now. I'll be quick. It's solar panels mapping their route to school and the energy that they work there. So there's tons you can do with the data. I'm sure, a lot of us don't always know about it, but, oh, there you go. Yeah, thank you, Chris.
Yeah.
The one on the bottom with the red is a heat map too. So it's showing how trees can provide a lot of shade and cooling. And so they're definitely beneficial within saving us the amount of energy for, especially in the summertime with the warm temperatures that we've been having. Yes, and I think that's it. So I'll pass it off to you, Sarah. Sorry,
All right, thank you. Thanks, Alicia, and to Chris as well for sharing a little bit about it. So clearly, we have many ideas from Allison from Relay and also from our TDSB team about how you can be bringing energy literacy into your classroom and hopefully some tools that you can play around with. I really like the idea of maybe with Earth Hour this Friday, going in and seeing if that does make a difference to the school's energy use. That would be really interesting. We are at 5 o'clock. Oh, actually 5:01. So I am going to jump quickly to share a few upcoming events for those of you who might be interested in joining. And then perhaps we can have people stick around for just a couple more minutes after if there are some people who would like to ask a couple questions. So we do have a few things coming up. Our next webinar is on April 3rd, and that's focusing on principles as catalysts for climate change education. Share that with an admin in your life if you think that this is something that could be incorporated into your school improvement plan, for example. That webinar is focusing on school leadership. And then TDSB team, did you want to speak to any of the other events?
Sure. Come to our middle school's student leadership conference at Downsview Park.
The link is included in the chat. I just put it in there. So if you're interested, just go to the website there.
Perfect. Thank you. And then we have our end of year Cultivating Connections, which will be at Gled Hill Public School this year in after school hours. So all of this information will be shared to people through the TDSB EcoSchools newsletter, correct? Yes.
Absolutely.
Awesome. So thanks for joining so much today. I think we will officially end things there, but if people want to stick around, if you have any questions for any of our presenters today, you are welcome to stick around for a few minutes to ask. So thank you, everyone. I hope you have a great evening.